Welcome to this new video tutorial. In this tutorial, we'll be working through 2000 step 2, question number 1. Okay, so let's get started. Okay, so it says that a number of the form 1 by n, where n is an integer greater than 1, is called a unit fraction. Noting that 1 by 2 equals 1 by 3 plus 1 by 6, and 1 by 3 equals 1 by 4 plus 1 by 12 gets a general result of the form 1 by n equals 1 by a plus 1 by b. Okay, so let's tackle the first part of the problem. So n is larger than 1, is an integer larger than 1. And 1 by n, where n is an integer larger than 1, such fractions are called unit fractions. Okay. And the question says that 1 by 2 equals 1 by 3 plus 1 by 6, and 1 by 3 equals 1 by 4 plus 1 by 12. By noting these two results, guess a general result. So my first guess will be there is a difference between these two numbers, and if we multiply these two numbers, we're going to get the third. So okay, it may be 1 by n equals 1 by n plus 1. There's a difference between 1 plus 1 by n times n plus 1. Okay, so so we multiply it out. Yes, so 1 by n equals 2 n plus 1 by n times n plus 1. Now, as n is larger than 1, n plus 1 will be larger than 2, and n plus 1 will not be equal to 0. Therefore, we can cancel these two things. Remember to mention this because in most of the cases, dividing by 0 is not allowed, so you must mention that clearly. Yes. So my first guess will be 1 by n plus 1 by a plus 1 by b. Oh, sorry. 1 by b, where n which equals 1 by n plus 1 plus 1 by n times n plus 1. Okay, so a equals n plus 1. And b equals n times n plus 1. Okay, it can be the other way around. Yeah, so that doesn't matter. Yeah, so we finished the first part. Okay, so let's move on to the next part. Okay, and hence prove that any unit fraction can be expressed as the sum of two distinct unit fractions. Okay, so now we worked out earlier that 1 by n equals n plus 1 plus 1 by n times n plus 1. Now, when if n equals 1, then n plus 1 equals 2, which will also equal n times n plus 1, because, it's 1 times 1 plus 1. So, if n equals 1, then these two numbers will be the same. So, the unit fraction 1 by n cannot be expressed as a sum of two distinct, it cannot be expressed as a sum of two distinct unit fractions. But, the question clearly states that n is larger than 1. Therefore, for all n larger than 1, n plus 1 does not equal n times n plus 1. Therefore, any unit fraction can be expressed as a sum of two unit distinct fractions. Okay, so we finished this part. Okay, let's move on to the next. By writing 1 by n equals 1 by a plus 1 by b, okay, in the form a minus n, b minus n equals n squared, and by considering the factors of n squared, show that if n is prime, then there's only one way of expressing 1 by n as the sum of two distinct unit fractions. Okay, so although in this question you're not required to prove how exactly you get this, you could easily work that out, but I'll just show you how exactly you get from this equation to this. So take this equation here and then multiply it out. ab minus a plus b n plus n squared equals n squared. These two cancel, and n equals ab by a plus b. And then 1 by n equals a plus b by ab. Okay? So, and then if you make this into fraction with a single denominator, then you're going to get this. So, yeah, that should be pretty easy. Yes, okay. So let's finish this part. Now, a minus n, b minus n equals n squared. Okay? Then what are, if n is a prime number, so it has no other factors other than itself or 1. Therefore, the only way to express n squared in terms of its factors are either n squared equals to n squared times 1, okay, times 1, or n times n. Okay, these are the only two ways to express n squared as a product of its factors. So, let's take the first case. If a minus n, b minus n, okay, equals n squared times 1. Okay, in this case, okay, remember that a is an integer, b is an integer, n is an integer. So these a minus n and b minus n must be integers. So a minus n equals to n squared, okay? Then a equals to n times n plus 1, okay? And then b equals n plus 1, right? Because you equate a minus n to n squared and b minus n to 1. So you get these two numbers. And for, as you know, that the number 1 is not a prime. Okay, so not 1. Okay, so n, what do you mean prime numbers? Prime numbers are natural numbers which are larger than 1, which cannot be, which is not divisible by any other number other than 1 or by itself. Okay, so therefore n must be larger than 1. So a will not equal b. Okay, a will not equal b, and 1 by n can be expressed as 1 by n times n plus 1 plus 1 by n plus 1, because these two will be distinct numbers. So it will be different. It will be different. So it can be so 1 by n can be expressed as a sum of two distinct unit fractions. Okay, so that's fine. So let's check the second case, which is n times n. Okay, in this case, a minus n equals to n, and b minus n equals n. A equals b, which equals 2n. And of course, we can express 1 by n equals to 1 by 2n plus 1 by 2n. But the question clearly states that prove that there's only one way to express 1 by n as a sum of two distinct unit fractions. So 1 by n equals 1 by n. So it's not distinct. So this case shouldn't be considered. Okay, so this is an invalid option. Now, so therefore, if n is a prime number, there is only one way to express it as a sum of two distinct unit fractions. Okay, 1 by n equals. Okay, so we finished this part of the question. Now, yes, okay, so now let's move on to the next. Prove similarly that any fraction of the form 2 by n, where n is a prime number greater than 2, okay, n is a prime number, n is a prime, and n is greater than 2, where n is a prime greater than 2 can be expressed uniquely as the sum of two distinct unit fractions. Okay, so, yes, so n is a prime and n is a prime and n is larger than 2. Okay, so n is a prime and n is larger than 2. Then we clearly see that, okay, take our original equation here, take this equation here, okay? Then multiply it by 2. Multiply both sides of the equation by 2. You're going to get 2 by n equals 2 by n plus 1, okay? Plus 2 by n times n plus 1, okay? Now we know that this thing here, we proved this, so this is true. And if you clearly see that if n is a prime number, okay, if n is a prime number larger than 2, okay, 2 is the only prime number which is even, okay? So any prime number which is larger than 2 is an odd number. And odd number plus 1, okay, the number 1 above the odd number. Let's say, for example, take 3, 3 is a prime, okay, plus 1 equals 4, okay? And let's say take 11, 11 plus 1 equals 12. So all of those numbers, any odd number plus 1 is going to be even, okay? And similarly for n times n plus 1, okay, take 3, 3 times 3 plus 1, which equals 12, okay? N is odd, and n plus 1 is even. So odd number times even number gives you an even number, okay? So basically, yeah, so basically your n times n plus 1 and n plus 1, both of these numbers are going to be even. If provided n is a prime number larger than 2, okay? So if both of these two numbers are even, then 2, if this is even, if n plus 1 is even, then it's going to be some number 2n, okay, where n is an integer. So if you divide, so 2 by n plus 1 becomes 2 by 2n, 2 cancels, and we have 1 by n, okay? And let 2 by n times n plus 1 equal, let's say, 2 by, n times n plus 1 is even, so n times n plus 1 equals 2z, okay? Keep it as 2z, where z is an integer. And then 2 by n times n plus 1 equals 2 by 2z. 2 cancels, and you get 1 by z, okay? Therefore, if n is a prime and n larger than 2, then as n plus 1 is n times n plus 1 are even numbers, we conclude that 2 by n equals, can be expressed as 2 by n equals to 1 by n plus 1 by z, where n equals n plus 1 by 2, which is not equal to n times n plus 1 by 2, and z equals n times n plus 1 by 2, which is not equal to n plus 1 by 2. Okay, so for any number larger than 2, n times n plus 1 and n plus 1 will be two different numbers. So we conclude that 2 by n can be expressed as 1 by n plus 1 by z. Okay, so it can be expressed as a sum of two unit distinct fractions. Okay, because because they're even. Okay, so yes, and n and z will be numbers. Okay, obviously it will be numbers larger than 1, and it will be integers. M and z will be integers because it is both m and z. Both n plus 1 and n times n plus 1 are even numbers. They can be divided by 2, so m and z will be integers. Okay, so yes, so that's it. Yeah, we have proved this part of the question can be expressed as a sum of two distinct unit fractions. Okay, so that's it. We approved. Okay, thanks for watching this video. Please share this video, subscribe, and please subscribe to my channel. And I hope this video was useful for your preparation for STEP. And good luck for STEP. And hope to see you guys in Cambridge. Bye.